Okay, now there are some important information regarding the bus coupler and the bus section. As we discussed before, the CT of any feeder to be included in the measuring system, at least one of the two bus bar disconnector must be closed, either Q1 or Q2. But for the coupler and section, the CT measurement to be included in the measuring system, it doesn't depend only on the disconnector status, but also on the circuit breaker status. So to include the CT measurement, CT1 and CT2 for the bus section or the bus coupler into the measuring system, the two disconnectors must be closed and also the circuit breaker. Okay, in this case he told you the bus bar protection excludes the bus tie breaker CT from evaluation under the following conditions. It means he will not take the CT measurement into the measuring system if the bus tie breaker is open. And he is telling you here the bus tie breaker measurement is blocked when the circuit breaker is open in order to trip the bus bar section effectively, concerning for a fault between the CT and the bus tie breaker. What's the meaning of this one? Let us imagine now that the CT measurements to be included in the measuring system only depend on the disconnector status and it doesn't depend on the circuit breaker status. So in this case, bus zone 1 is starting from here up to the circuit breaker. Bus zone 2 also start from here up to the circuit breaker. But for protection zone 1, it will start from here up to CT2. And the protection zone 2 start from here, from CT1 up to here, to make overlapping. In this case, if a fault happened at F, the fault now is included in both protection zones, protection zone 1 and protection zone 2. In this case, both bus bars will trip, even the fault on only bus 1A. But on the other hand, if the circuit breaker status here taken into consideration, it means if the CT measurement to be included in the measuring system, the circuit breaker must be closed, the bus zone 1 will also from here up to the circuit breaker, bus zone 2 also from here up to the circuit breaker. For protection zone 1, now if the circuit breaker is open, it means the protection zone 1 from here up to the circuit breaker. And for protection zone 2 also it will start from here up to the circuit breaker. In this case, if a fault happened here at F, all currents here will be added together to feed the fault. The current is passing through CT1. Okay, it means CT1 will make disturbance for bus zone 2. No, why? Because the circuit breaker is open. So the current passing here through CT1 will not be reflected to the measuring system of bus zone 2. In this case, bus zone 2 will be healthy and stable because CT1 already is excluded from the measuring system of bus zone 2. Okay. Also, the CT measurements of the bus coupler is excluded from the measurement in case of any two bus disconnectors are closed on this section. For example, here we have one feeder, Q1 and Q2 are closed, so these CTs are excluded from the measuring system. Already here, if any fault happened, both bus bars will trip, as you cannot isolate only one bar because both disconnectors here are closed, so you have to trip both bus bars. Okay, then why we are using two CT on the bus coupler and bus section? Why not only one CT? Okay, I will explain for you. Here is telling you the behavior of the relay in case of having only one or two sets of CT. First, we'll start we have only one set of CT available here. In this case, if we have only one CT here, the bus zone is a start from here up to the circuit breaker. Also for bus zone 2, start from here up to the circuit breaker. But for protection zone 1, it will start from here up to the CT only. and for protection zone 2 it will start from here also up to the CT. So he's telling you here, when the bus type breaker is occupied with only one set of CT, fault on bus zone 2 here, if a fault here on the bus zone 2 here up to any place at bus zone 2, here or here or here, whatever, are tripped immediately and discriminatively in protection zone 2. Because if any fault happened here, if the circuit breaker here for the bus section is closed, all feeder currents here will add it together to go feed the fault. So actually all feeder currents here will be stable with the bus section CT measurement, so only indicating a fault on bus zone 2, and bus zone 2 will trip immediately. Okay, then fault on bus zone 1, but not between the CT and bus tie. It means from here up to here. Any fault happened in this place, only bus zone 1 will also trip immediately and discriminatively. Okay, it means only bus zone 1 will be tripped and bus zone 2 will keep healthy. Okay, but if we have fault here between the circuit breaker and the CT, what will happen? As shown here in the graph, bus zone 1 is from here up to the circuit breaker, bus zone 2 from here up to the circuit breaker, and the protection zone 1 ended here at the CT, and also protection zone 2 from here up to the CT. So in case of fault between the CT and circuit breaker, it means this fault is included in protection zone 2, not in protection zone 1, because all currents here will be added together, going to the fault, passing through the CT, so the bus section CT will be stable with the feeder CTs. It means bus zone 1 will be stable, but bus zone 2, all currents here added together going to feed the fault and not stable with the bus section CT, because all of them going here to the fault, not passing through the bus section CT. In this case, bus zone 2 will indicate a fault, and all feeders connected here to bus zone 2 will trip immediately, and also the bus section. After the bus section tripped, the circuit breaker indicates it's now open. It means the CT measurement of the bus section will be excluded from the measuring system. In this case, bus zone 1 now will find there is currents going out from the feeders toward the bus bar and going to the fault without being stable with the bus section CT. In this case, bus zone 1 will also trip. But actually, bus zone 2 first, we have two problems here. First thing, bus zone 2 is tripped, and this one is wrong tripping because the fault is not included in bus zone 2. And other one, the faulty bus is tripped but with time delay. This time delay equal to the reclaim time delay. You remember when I told you, I will tell you later about here in the circuit breaker, we have another option called reclaim time. I will tell you what's the meaning of this reclaim time. Okay, what's the meaning of reclaim time here? To understand the reclaim time, we have to study two types of faults, or two different places of faults. If I have fault here on bus zone 2, and if I have fault on bus zone 1 between the CT and circuit breaker. First, in case of I have fault here on B, here protection zone 2 will trip, include also the bus tie circuit breaker. All feeders here will trip, and also the bus tie circuit breaker. Okay, if the bus tie circuit breaker now giving indication that it's open now, okay, so the CT measurement of the bus tie will be excluded from the measuring system. But if the circuit breaker is open, it doesn't mean the circuit breaker is only open, because there is also some arc, or there is arc after the circuit breaker is open, still passing between the fixed and moving parts of the ball of the circuit breaker. It means although the circuit breaker giving me indication it's open, but still arc passing, it means actual primary current passing. In this case, if the circuit breaker reports it's open, but the arc is still passing, it means all feeders here is still feeding the fault at point B. And because circuit breaker reports it's open, this CT of the bus tie is excluded from the measuring system. It means now bus zone 1 will indicate unstable condition and it also will trip, and this one is wrong tripping. So he put here one setting which is called recovery time, or you can say reclaim time. For this reclaim time, he's telling you that if the circuit breaker is opened, the CT measurement of the bus tie will be included in the measuring system for a time delay equal to the reclaim time delay. After this reclaim time delay, the CT measurement of the bus tie CT will be excluded from the measuring system. What's the benefit of this one? The benefit that if the circuit breaker reports it's open and there is still some arc, the CT measurement is still available, so the feeder currents here will be stable with this CT current feeding the other fault until the arc actually extinguished. So now everything will be healthy. So this time delay for the reclaim time or the recovery time of the circuit breaker must be more than the circuit breaker opening time and the arc time to cover all these times. Okay, and here you'll find here explanation in the paper. But as the reclaim time solve a problem for me, it also make another problem. What's the other problem? If there is a fault on A, if there is a fault here, the fault is included in protection zone 2, not in protection zone 1. It means the bus zone 2 will trip, all feeders here will trip, and also the bus section will trip. After the bus section will trip, already the fault here available, still available in bus zone 1. So bus zone 1 must trip, but actually bus zone 1 will not trip. Why? Because all feeder currents here will be stable with this CT measurement, because all currents here going and going out from this CT to feeding the fault. Until the reclaim time finished, then this CT measurement will be excluded from the measuring system, and now bus zone 1A or bus zone 1 will indicate a fault and a trip. So if a fault at B, it's okay because it inhibit wrong tripping of bus bar 1A after the bus tie breaker open. And in case of a fault on bus zone 1A between the CT and the circuit breaker, it added a delay time in the tripping of bus zone 1. So the recovery time now has one benefit and one disadvantage, we can say. So here he go and he use two CTs. What's the benefit now of using two CTs? First, if we have a fault here, actually bus zone 2 will trip and also bus tie, and the reclaim time will inhibit bus zone 1 to trip by mistake. But if there is a problem here between the CT and circuit breaker, or between the other CT and circuit breaker, actually as you can see from the figure here, this one is bus zone 1 and this one is bus zone 2. Protection zone 2 is extended up to this CT, and protection zone 1 is extended up to this CT as overlapping. So now any fault between the two CTs and circuit breaker is included in both protection zone 1 and 2, so both buses will trip instantaneously instead of tripping with a time delay. Also, there is one important note: the manual close command. Manual close command here very important for the bus section and the bus coupler. Why? He's telling you, in case of closing onto an existing fault, for example, I need to energize bus zone 2 from bus zone 1, and actually still here there is no feeders is connected, no feeder connected here, no any feeder is connected. Okay, and there is a fault here. This fault may be closed grounding isolator or forgotten grounding clamp. Hence, when I give close command to the bus section, what will happen? During the travel of the moving parts of the circuit breaker, there will be an arc between the moving part and the fixed part of the circuit breaker. In this case, there is current will pass from here, from all feeders here, and going to feed the fault. But still the circuit breaker is not closed. It means the both CTs here are excluded from the measuring system. It means all currents here is going out from this bus and not stable with their CT, with the bus section CT. It means bus zone 1A will indicate a fault and it will trip. So he's telling you here, the arc ignites before the circuit breaker reports it is closed. The measuring system for bus zone 1 is unable to measure the outgoing fault current toward this bus zone 2 because the measurement of the bus type breaker is still blocked. Hence, a differential current equivalent to the fault current is therefore created, and the measuring system for bus zone 1 trips bus bar 1. And already bus zone 2 has no any feeders connected, so there is no benefit to give trip command. Give trip command to whom? All feeders are already tripped. Okay, so here he's telling you here, in order to prepare for closing the circuit breaker onto an existing fault, closing ground isolator or forgotten ground clamp, the measurement has to be reinstated. The measurement of what? Of the bus section CTs has to be reinstated before the circuit breaker is actually closed. And this one is achieved by activating the bus bar protection signal, which is the close command. So if you go here, open setting or configuration, binary module, where is the bus section and bus coupler? It's already here. If you open the bus section, you will find here circuit breaker close command, and here the address for the signal. And also at the same time, the circuit breaker close command must be maintained until the circuit breaker close auxiliary contacts has definitely closed, because already if the circuit breaker auxiliary contact reporting it's now closed, already the CT measurement will be included again or reinstated again in the measuring system. But at least I have to check that when I give the binary input and remove my hand, like a push button, because this one is close command. When I give close command and remove my hand, the close command should be maintained or must be maintained until the circuit breaker close auxiliary contacts has been definitely closed. It means now the auxiliary contacts should be overlapped between my binary input and the circuit breaker feedback or closing status feedback. This can be achieved by configuring an input signal prolongation for the breaker close command binary input. Okay, so this one here, if you go to this binary input, you will find here prolongation of input signal. It means if you give the binary input and you remove your hand, even you removed your hand, there is a prolongation time for the input signal that the relay will indicate that the binary input is still activated. So this prolongation time must be greater than the circuit breaker closing time to make overlap. So if I give the close command and remove my hand, for example, the circuit breaker closing time is 60 milliseconds, I'll put here 100 milliseconds. Even I give just a positive edge and remove my hand, the signal or the relay will consider that the binary input is still activated for 100 milliseconds, which is enough to be sure that the circuit breaker is actually closed. Also, there is one comment also. To avoid any risk of maloperation, the protection must register every signal applied to the circuit breaker close coil, the manual close command, from local close command, from remote close command, from station automation close command, or from the auto reclosure. So it's better to take the manual close command from the contactor, or we can say from the contactor that giving the close command to the circuit breaker, and this contactor, as we know, is energized from the auto reclosure, from the local, from the remote closing command or station closing command.